Thank you for joining this presentation, folks. As usual, I will start with a couple of questions. Kubernetes, who is using Kubernetes? Okay, I would say 70% of the room. And that's like something that I keep seeing in conferences. Like in the last year or so, that number has been coming up and up and up, which is kind of like good. So my presentation today, it's about Kubernetes, how difficult it is, platform engineering, and how we are doing it. I think that that's something that we are doing because we need it, not because we want to do it. And then kind of like why in the cloud native space we are talking about enabling developers. It's something kind of new in that space, and we are just going to do more and more of that. So that's pretty much the agenda. That's what I described. I've been working with Kubernetes for 8 years now, and it's been so painful. It's crazy painful. Yeah, it is crazy painful. I'm a developer at heart, and since day one, I basically realized that we will need to start building a lot of tools to make it a little bit more easy. And that's mostly the reason why we are talking about platforms nowadays. But still, developers are not the focus in these communities. And I think that we need to do something about it, just help these communities to get there. So my name is Mauricio Salatino. I'm at Salaboy in Twitter. My DMs are open, so if you have questions or if you want to collaborate or work on open source, please feel free to reach out. I work for a company that's called Diagrid. We help people to run cloud-native applications in production with tools like Dapper and some other open source projects. And I'm involved in a bunch of different open source projects, contributing, collaborating, and just pushing some of these projects forward, again, towards developers. Some of these projects are not developer-focused, but they can enable developers to do a much better job. I'm also writing a book that's called Platform Engineering on Kubernetes, mostly because of these reasons, because there are like different projects that can help you go through this journey in a much easier way. And sometimes you don't have time to learn them all, right? So you need a way to actually map all these projects to different challenges and then just apply them in the right way. There is like a QR code there for that if you're interested, and also the 40% discount as well. You can get that, like ask me later if you want to. I will let you take some pictures, but that's all right. So where does the journey start? And if you have not been using Kubernetes, the main idea of this section is to make you think about what's coming for you. If you are looking into Kubernetes, I think that you will go through these challenges, and I'm planning to, I have like the draft already there, but I'm planning to publish a blog post with all these things, kind of like all the milestones that you will find in your Kubernetes journey. So the main reason to adopt Kubernetes, I would say, at least in my opinion as a developer, is to be able to deliver more software more frequently in front of your users. And that makes a lot of sense if you are like working with already kind of like with a cloud provider. By using Kubernetes and the Kubernetes APIs, the main idea is that you can deploy and run your applications in any cloud provider using the same tools and the same APIs. I think that that's a great advantage, but it will take you that far. It's not actually like the entire solution. So usually when you start looking into Kubernetes, you will see that what happens in companies and in organizations is that somebody starts learning Kubernetes, right? Before fully adopting it, somebody will need to learn how to use it, understand the advantages of using it, and of course learns about like containers and YAML files and the Kubernetes APIs. I think that the Kubernetes APIs are pretty good for developers. If you are a developer, you know how to interact with APIs. So it shouldn't be a problem. But containers, on the other hand, is something that we were not used to do as developers. Like learning how to containerize applications, it's not that difficult to do it wrong, right? Like you can actually do it pretty fast. You write a Docker file and you get it working. But doing it correctly for production use cases, that's pretty complicated. And for that, you need to actually learn a lot of stuff. So for like an individual to learn Kubernetes, I think that it's a great investment. Like if you learn Kubernetes, again, you can go and work for companies that are using different cloud providers, use the same tools and everything else. For organizations, that takes a lot of power, because you need to teach like a bunch of people to learn this. And then it raises the question, right? Like, does a developer needs to know about Kubernetes or not? Should they care or not? To some developers, that might be interesting. To some other developers, they don't want to know anything about it. The second challenge, something that I remember thinking about like after maybe a year of using Kubernetes, is that I will not have a single Kubernetes cluster. I will have tons of different Kubernetes clusters, different shapes, different sizes. They all use the same APIs, but you will need to manage them at some point. You will need to start thinking about how to manage more than one Kubernetes cluster and how to provision them, how to keep them updated and all that stuff. And that, again, not only takes time, but also takes money and creating a team that it's going to be dedicated to do that kind of stuff. And the thing that you will see when you have more than one cluster, more clusters and more important clusters, like, for example, having a production cluster or multiple production clusters, is that different teams will own these different clusters. So you need to start thinking about, the production environment is being owned by operations. They are going to harden that clusters as much as they can, but they are not going to be dynamically creating these clusters because usually, you have like them fixed and then you just run them in different regions or that kind of stuff. For staging clusters or quality assurance clusters, that might be a little bit more dynamic, right? Like you might want to create some specific clusters to test performance on a bunch of features, and for that you will need to have some kind of templating mechanisms to go and provision those clusters. And then on the other hand, depending on how your developers are used to work, you might have like smaller clusters for developers, or maybe you are just pushing developers not to use clusters at all. They might just use something like Docker Compose or not even containers for building their applications. You might have some clusters for CI as well, for testing things in CI and running integration tests. That all depends on the organizational culture and the maturity level on adopting Kubernetes. And you will see that, again, in this kind of like challenge, you will see different milestones inside and, maturity level growing up and growing up. It takes time until a company have developers working on top of Kubernetes on day-to-day basis. The next thing that you will find is that if you go to the CNCF space nowadays, you will have tons of tools, right? There are tons of tools, and these basically are tools that are expanding Kubernetes to do way much more than just running and deploying our workloads, right? If we want to do building your containers inside the Kubernetes cluster, you will have a tool for that. If you want to check for security or add policy, you will have another tool for that. Whitney and Victor did a great presentation this morning about choosing your own adventure because it is actually tricky. So what happens in organizations is that you will need a team that is looking at these tools all the time, and they are like in charge of curating and defining which tools are going to solve which problems inside the company. The nice thing about this is not, it's a problem because it's big, but it's very good because at the same time, all these tools are using the Kubernetes ecosystem, APIs, and tooling to provide different solutions. So no matter which tools do you choose in here, you know that they are all kind of like aligned in some way or another, right? Like that's theoretically, right? But when you go and check the tools, some of them are more aligned than others. So again, you need to kind of like keep an eye on these tools and have someone who actually understands how to choose from this list. The next conversation that happens inside companies about Kubernetes is multi-tenancy. If you start having multiple clusters, you need to figure out how to give those clusters to different users. And then you should ask the question of, okay, how isolated these users should be from one to each other, right? So if you, for example, are building development environments, do you want to have a single cluster with tons of different teams working on the same cluster? Or do you want to create one cluster for each? Creating one cluster for each might be too expensive. Creating a single cluster for everyone might not be the best because they might be interfering with each other's work. There are some limitations on Kubernetes and multi-tenancy, and this is very well known in the community. But sooner or later, that conversation will pop up in your organization. And finally, costs, of course, right? Like running Kubernetes is extremely expensive. I don't know the folks here using Kubernetes, but if you start going and creating clusters on Google Cloud or on Amazon, you are just basically paying a lot of money to just run Kubernetes. Remember that running Kubernetes, first of all, when you create a cluster, it's region-based, right? Like you create a cluster in a region. So if you want people from all over the world to access to that cluster, well, they will have latency. That will push you to create clusters in different regions and keep them running. And at the end of the month, you are going to get a big bill only for running Kubernetes, not for running your applications, just for running Kubernetes itself. So you need to take that into consideration. And cost effectiveness nowadays is a hot topic as well in this community. So I think that we will need to keep an eye on whatever we build on top of Kubernetes, we need to make it cost efficient as well. That's the main reason. All these kind of like topics are the main reason why the platform engineering buzz is happening in the CNCF space. There is a lot about like platform engineering. How do we build efficient, cost-efficient platforms that will enable developers and data scientists to build their workloads and to run their workloads on top of Kubernetes in a multi-cloud space. The main thing that you will hear about platform engineering, it was super fun today on today's keynote, like the platform engineering movement started like around 2017, I think that actually makes me think about the maturity level that we are having in the cloud native space, right? Back in 2017, it was all about cloud provider creating their own platforms, right? Like they had a lot of services. They needed to have a consistent way of providing an experience to consume this huge amount of services. Now we are seeing the same in the CNCF space. We have a huge amount of tools, but we need a team, a specialized team that figures out which tools do we need to use to solve our challenges. So the idea in platform engineering nowadays, you will see that it's all about creating specialized teams that will be in charge of making these decisions. And their main purpose there is to enable teams like developers, data scientists, and the operations teams to do an efficient work. Remember, the main reason why we are adopting Kubernetes is because we want to deploy and deliver more software more efficiently. We need to have this kind of coordination and expertise inside the company to enable that. And another big change compared to DevOps, I really liked the joke this morning. I actually laughed internally. I didn't laugh because nobody else was laughing, but it's really interesting. When I think about DevOps and platform engineering, I think that they are extremely related. It's pretty much following the same journey. But when we talk about building platforms, we are talking about creating software, right? In this case, there is a concrete piece of thing that we need to build for our organization. When we thought about DevOps, at least in my perspective, it was all about practices and making sure that teams collaborate, that we have people working with different skills together. In this case, we are building concrete software. So we talk a lot about building kind of like our own organization platform, and you will hear things about like platform APIs, self-service, cross-cutting concerns, golden paths. Those are the things that you will hear in these kind of conversations, and I think that it's pretty important, right? We will be talking a little bit more about platform API, self-service, and cross-cutting concerns, but the idea of creating a platform, a piece of software that encodes in a way, how do we take changes from developers and put them into production, makes a lot of sense. It actually makes a lot of sense. Implementing that, I think that it's pretty hard and pretty company organization dependent, but it actually makes sense. So we will see how this develops in the next few years. If you haven't been reading anything about platforms, I would recommend you to take the white paper created by the Tag App Delivery in the CNCF, where this community is trying to come up with all the terms and all the definitions about what do we mean by platforms. I strongly recommend you to check that and get involved if you are into building platforms on top of Kubernetes. So I have like a very simple example platform that I built that I've been showing kind of like over the last year, because white papers, platform engineering, books, they are all good, but having something that you can run in your own laptop and that you can experiment, I think it's better, because it will give you kind of like some hands-on experiments on how does it work and how it should feel for like the target users. So the example that I have is that I've created a platform on top of Kubernetes, extending the Kubernetes APIs. I've installed some tools in a Kubernetes cluster, and I want to provide this experience to my application development teams. I want my application development teams to say, hey, I want a new development environment. I will send a request to the platform. The platform will take that request. It will use some tools, and it will provision to this team a new environment that they can use. And this environment will be kind of like an isolated environment where they have some tools installed, but also the application that they are planning to change. So that's kind of like the experience that I wanted to build. You can see that the platform already created my environment, so the development team can just go and connect to that environment. Let's see how that goes. For implementing this example, I've used two of the CNCF projects. One is called Crossplane. How many people here knows about Crossplane? We heard about this morning. Okay, just a few. Crossplane, you need to imagine like Terraform, but for Kubernetes. You can create cloud resources with it, right? Like it gives you a way of creating, cloud resources like S3 buckets, databases, Kubernetes clusters, whatever you want to create in AWS, Google Cloud, or Azure using the Kubernetes APIs. VCluster, on the other hand, allows you to create like cost-efficient virtual clusters inside a big Kubernetes cluster. So let's take a look at how this works. And if you don't know these tools, this is kind of like the perfect setup, right? Like because the idea of creating a platform is encapsulating all these tools, so developers doesn't need to actually understand how these things work. So let's do that first demo. It's a pretty simple demo, but let me show you that. So I'm here in my terminal. I'm connected to my platform cluster now. So imagine that I have created a platform that exposes a set of APIs, and I'm already connected to it. because I've extended the Kubernetes APIs, I can use all the Kubernetes tooling in order to interact with this platform API. So what I have here is I have a new resource type in Kubernetes. This is how Kubernetes works usually. This is how you interact with the Kubernetes APIs. You create some resources to define what you want, and you can extend Kubernetes to understand custom resources in this case. So I created a resource type kind environment that allows me to define a name here. This is the name of the environment that I'm requesting. I can use some labels to be able to say, I want an environment that has these kind of like features. In this case, I want the development environment. And then I have this last section here with some parameters. In this case, I'm saying, I want to deploy my application in this environment as well, but I also want to install a database so my application can store some data in it. You can extend this concept to add more parameters and enable the teams to parameterize their environments depending on their needs. And also with Kubernetes and using labels, usually what we do is we use this type, like the environment type, as an interface, right, where we can provide different implementations. So I can say, I want a staging environment, and that staging environment will be bigger than my development environment, for example, or have different tools in it. Right? So because it's a Kubernetes resource, I can apply this resource. This is how you interact with the Kubernetes APIs, right? So I will apply the environment resource, and what I should have in return is the platform telling me, okay, yeah, I received the request. I will create this environment. This is not a synchronous API. I just get the acknowledgement that the resource was received, but there will be kind of like called the Kubernetes reconciliation loop, right? Like Kubernetes will try to provision this environment for me and let me know, if the environment is ready or not. And because again, it's a Kubernetes resource, I can actually list all my environments here. Let me do that again, and you can see that the platform is actually recognized the request, but it's not ready yet. So it's provisioning some resources that I need for that environment to work. Of course, if you are creating a platform, you should try not to expose the Kubernetes API to your teams if they do not know Kubernetes. So you can build actually an abstraction layer on top. Just exposing maybe a dashboard using something like Backstage or using any other tool that enable different teams to basically perform the same request without knowing that they are talking to a Kubernetes APIs. But in my opinion, having the Kubernetes API there, it gives you that a space where you can actually use all the Kubernetes ecosystem tools for building and and mashing up different tools and different solutions. So at some point, that environment will be ready. I think that it's ready now. I think that I trust that ready flag. So what I will do now is I will just mimic how a team will connect to that environment. Remember, I'm connected to the platform API. Now I will connect to this environment to access my application. And in order to do that, as I mentioned before, I used VCluster to actually connect there. And I used VCluster to create the cluster, but I also used the VCluster CLI to connect to that cluster. So now I'm in a different cluster. I can just check here my namespaces. I'm in a completely different context. So I can go as a development team here and install my tools, install whatever I need. I will just list here some services so I can actually access the application by clicking in this link. Let's see if it works. And there you go. So I have an application here. Let me clean that up. I have an application that basically allows me to save some data. So I can do something like hello GOTO, right? And that basically is stored in a database in a persistent storage. And then I have another section here of the application that gets these notifications asynchronously about what's going on there, right? So it's a pretty simple application. I will go a little bit deeper on the application in kind of like in the next demo. But for now, you can see that I have a new environment with the application running with some tools installed. And you can see here in the URL that this is the instance for the team that just requested that new environment. If another team goes and requests a different environment, they will have a different kind of like URL for a different instance of the same application, right? So you can enable multiple teams to do different changes and just work with whatever they need to do with the application ready for them to change. So that's the first part. Just, again, trying to recap a little bit what I did is that I connected to my platform API. I sent an environment resource request to the platform API. The platform used Crossplane and VCluster to create an isolated environment for me to work. And at the end, I have the developer connecting to that environment and accessing the application, right? I'm using these tools that I will be talking a little bit about later, like Knative and Dapper. But for now, kind of like that's the interaction that I would expect, from a platform, from an internal development platform in my company. But going back again, so I think that in the CNCF, like in the cloud native space, we are getting pretty good at doing this kind of stuff. We are pretty good at extending Kubernetes to do things that we need to do, right? Like, and to solve custom scenarios for different environments and different organizations. We are getting really, really good at creating cloud resources on multiple cloud providers, all using the Kubernetes APIs. But again, we are not aiming for developers just yet, right? Like, we are good at creating cloud stuff using the Kubernetes APIs, but then, when developers are developing their applications, they are expecting way much more. And we need to add more stuff for developers to be more efficient, because that was the first reason why we wanted to adopt Kubernetes in the first place. So in this presentation, I wanted to touch quickly on two topics that I think that they are becoming more and more important. The importance of experimentation, enabling teams to deploy more versions faster and not stop them whenever they have a new version ready to be tested. And then defining the platform boundaries and platform capabilities. I think platform capabilities, that's the way that I'm calling it. Maybe in the CNCF we will come up with a different term for calling these things, but that's kind of like what I have today. So for experimentation, I wanted to touch on Knative. How many people knows what Knative is? Okay, just a few again, which is good. Knative is associated a lot with serverless, and it's a Kubernetes extension that allows you to basically scale up and scale down your workloads. Something that you cannot do with plain Kubernetes is downscale your applications to 0, right? Like, just whenever your applications are not being used, actually removing the container out from running. It's not something that you can do with Kubernetes. You can do some manual things with it, but Knative takes care of doing that, and also like buffering requests for whenever there are no like replicas of the application running. So Knative is something that when you have a Kubernetes cluster, you can install Knative into that cluster to enable that cluster with a lot of serverless features, let's say. But it's way much more than that. The first thing that you can do with Knative, something that you will notice, is that if you know Kubernetes already, you know that you need to understand about what a deployment is, what the pod is, what an ingress is, what the service is. With Knative, what we try to do is we kind of try to encapsulate all these concepts and manage all these concepts for the users. So with 10 lines of YAML, you should be able to quickly deploy an application and then have a URL to access to that application. So it's taking a bunch of concerns and managing those concerns for you. So in this case, I'm showing that, but actually, what we are trying to solve here is to try to do more like a containers as a service approach, right? Like, cloud providers are now all offering, cloud running Google container services. I think it's called in Azure. They all have different names, but it's pretty much the same. It's give me a container, I will run it for you. You don't really need to worry about Kubernetes or anything at all. So this is pretty much what we are trying to do with Knative. It's like a simple YAML where you just specify your COBOL app container image, and then it will run it for you no matter what it's in there, right? And I think that it's pretty cool because it's simplifying a little bit of the cognitive load that teams needs to understand about Kubernetes just to get started faster, but it's also adding a bunch of other features. And one of the things that I believe that enable teams to experiment is the idea of advanced traffic management. When you install Knative, you install also like a networking layer that will enable you to do a bunch of things that I believe that are really important for teams. And that's pretty much, for example, running different versions of the same applications at the same time. And then it will allow you to choose how you route traffic to these different versions. What you will be enabled to do with this is to, as soon as you have a new version, you can just deploy it. You can just let it there and then start rolling out traffic to that version to see how it goes. And you can do that like using different approaches. One is percentage-based traffic routing. You can say, okay, 80% to the stable version, and I will slowly start transitioning traffic, to the newer version. Or you can use tag or header-based routing, where you can say, okay, I will create like a specific tag, so when people point to that tag, it will be redirected to the new version. Or you can do header-based routing, which is basically if my client is setting this specific header, Knative will read that header and it will redirect to that version. Again, the idea of enabling teams to keep deploying versions and then, having the mechanisms so you can actually try that new version before forwarding all the traffic to it. And as I mentioned before, because it's very associated with serverless, if you have HTTP applications that are not receiving any request, Knative can automatically downscale those applications to 0, and it will take care of buffering requests when they are arriving and there is no replica to answer that request. It will buffer the request, wait for the new replica to start, and then forward the request to be processed. It works in the same way when you need to scale up, right? Like you can actually define per application the concurrency policies on how many requests the application can support at a single time. And if you're going above the threshold, you will be automatically scaled up. So the demo, like the second demo, it's pretty much using the development environment that I've created before to make some changes and also to show some tools. So here I'm connected to the platform cluster, but I will switch to VCluster. So I will switch again to the cluster that I was connected before. And I'm here in the path of the front-end application that I showed before. Right? Like my application is composed by different services. I'm here editing the code for the front-end application. So let's go here. I will make some silly changes, like for example, change the color of the application. That's a silly change that I can do, but also I want to change the version of the application somewhere here. I have it somewhere. It's like a very complex application, as you can see. So let's make that change. I will use a tool in the Go community that it's called KO. It was created by Google. So very early on in the Kubernetes journey, they wanted to make all this iteration loop pretty fast. So by just running that command, I don't need to have a Docker file or anything. I can compile the new changes for my Go application that contains the frontend, push this container into my Docker registry, and update the configuration of the front-end application that was deployed in that service. So if I list the pods, you can see that the second revision of the application is being created, and that the old revision was removed. And if I'm a developer, this is what I want, right? Like I want to try my new changes. So if I go back to the application and hit refresh, you will see that now I have the new change applied already. So if I say hello here, v2, let's see, well, the application should keep working, right? Like I only changed the front end, and the notifications are there as well. So that's one thing that as a developer you would do, and that's pretty good, right? Like it's a good development cycle, right? Like I'm changing things, I'm deploying to my development environment, everything works well. But now if you're in a staging environment, or let's say safe production environments, what you want to do is you want to use that advanced traffic management functionality. And usually that sounds really complicated, but what Knative does is abstract away that and just give you a simple interface to deal with these kind of like complex patterns. So what I will do is, because I don't want to type this, I will just copy these 5 lines, let's say. And I will modify the deployment of this application now to use these traffic rules. So I will edit this Knative service here that is called frontend. And of course, this is YAML. Again, same as Victor mentioned this morning. You will never do this. You will never edit this. You will use some kind of like GitOps approach to change your resources. But the point of this, of showing this here, I don't know if you can see, there is like this traffic section. It basically says 2 things. It says we will want to show, like we want to forward 100% of the traffic to the stable version. That's the blue version, right? And for the latest revision, which is the red version now, I only want to forward traffic if you mention this tag, and we will see how that works now. So let me apply this. And again, I don't know, I was developing applications 15 years ago, and when I was developing applications, I never thought about the idea of running multiple versions of the same applications at the same time, right? But with these tools, you can see here that now I have both containers up and running. So both of my applications are up. And in this case, both are up because I have rules that tells me that in some situations, I want to forward requests to that. I can configure Knative to actually downscale those applications if nobody's using it, but for now, you will have an instance there. So if I hit refresh here, we will see that we will go back to version 1. That's the blue version. That's where we are forwarding 100% of our traffic. But now if I want to point to the red version of the application, I can use here like the tag red dash front end, hit enter, and now I'll be redirected to that other version. As I mentioned before, like tags can be accessed by changing the URL, but sometimes you don't want to change the URL of your application. If you have a public domain, you don't want to change the URL to access the new version. So instead of adding that red here in the URL, you can add a header with like a specific Knative header with that value, with value red, and Knative will read the headers on the request and redirect customers to this version of the application. That gives you the power of, for example, if you have mobile clients, to actually use these headers when they are requesting the content from the remote server and then just serve a new version of the application. You can do also like traffic mirroring and a bunch of other things like canary releases, A/B testing, and all that stuff with these features. That's why Knative is focused on providing all the building blocks so you can build this kind of stuff and use these kind of mechanisms. So that's the second demo there. Let's go for a quick recap. Well, quick recap now, like I just changed the background of the application. I deployed it, and then I used the traffic rules to actually create this scenario. But again, you can implement different release strategies, different patterns to enable your teams to experiment and to catch early the issues that they might have in versions. You don't wait for the version to be fully tested and everything running. You can actually deploy features as they are being merged and then just start testing with real-life traffic or with mirrored traffic as well. And I think that takes me to the next thing, right? Like enabling teams with different release strategies, with mechanisms that allows them to keep releasing software in a safe way, where you can actually try the features before putting all your customers in the new version. I think it's quite well. And that takes me to talk a little bit about platform capabilities. And when I'm talking about platform capabilities, I'm talking about the capabilities that we can offer to our teams, to our development teams, and to our application developers to consume from these things that we are building, right? Like if we are giving them like an environment, when we give them an environment that is Kubernetes-based, do we want to expose the fact that this is running on Kubernetes or not? Do we want to give them full freedom to create their applications using any Kubernetes projects and to interact with different things? Maybe we do. Maybe we are not in that space right now in our maturity in the organization. So something that has been coming up more often now is the idea of having different capabilities provided by the platform team so application developers can consume. So what you will see in that side, in this kind of like column here, is stuff that we will expect to have in any Kubernetes cluster. Right? Making sure that when we deploy applications, we can observe them, we can monitor them, we can see the traces of our application is something that it's mostly like a given, right? Like you cannot run applications in production unless you know how they are running, right? Stuff like resiliency, dynamic scaling, are things that sometimes we have, sometimes we don't, but I would say that most of the time it's really good if we have them. And traffic management, again, that like dynamic scaling and traffic management and resiliency are topics that are usually associated with service meshes in the Kubernetes space. Sometimes that's too complex for the organization, but I would argue that every organization will like to have some of that. Now, this other column is a little bit more developer focused, right? Like we can say that, I don't know you guys, but how many of you are building applications that are storing or reading data from a database or a storage? I would expect 100%. And if you are not like doing that, that's fine. But maybe your applications are consuming or exchanging messages. So they are like common things, right? Like emitting events in an asynchronous way using Kafka or RabbitMQ or any message broker. You're going to be doing these things, right? Like why we cannot get some common patterns, just bundle them somewhere so our developers can use that. Things like feature flags and release strategies, as I mentioned before, are things that will enable your teams to experiment more and to go faster, right? Feature flags is a perfect example. You want to deploy new stuff, and then you want to delegate the responsibility of enabling a certain feature that you want to try it out, maybe to a different team, maybe to the business, right? You don't want to deploy like one version and enable all the features at once because maybe one is failing and it's bringing down the entire thing. For that, I would love to say that it's not me defining these topics, right? Like there are a bunch of organizations that are doing this kind of stuff. I strongly recommend this article by Wix Engineering. Wix is a platform basically to enable other teams to build websites on top of their service, and they have around 2,000 plus developers. So they are a pretty large organization. They are all building services, and basically what they have recognized is that they need kind of like this layered approach to give these teams the right tools for them to do their work. And they have a bunch of shared concerns that they have identified for all the services that they are building. So basically, they are recognizing these things. Most of our applications are going to do these things. So we need to provide developers with all these things out of the box so they can focus on building features and pushing their services forward. So you can see here, like there are like gRPC, REST, right? Like services communicating to each other using these protocols. If you are doing something asynchronous, they are just defaulting to Kafka. They have chosen that messaging approach. But then stuff like distributed tracing, authorization, authentication, service discovery, security, and all that stuff are things that you are going to expect to have in your applications. There is no point on pushing developers to learn how to do these things because they will find 10 different ways of doing it. It makes a lot of sense for a large organization to start standardizing on this. And then you can see here like feature toggles, feature flags in there, A/B testing, something that I was mentioning before as well, related to release strategies. So it's becoming more and more of a pattern. If you read the article, they are basically describing a way to create these shared like libraries or functionalities for all your services to consume. And that's what takes me to the project that I'm working on right now, which is called Dapper. That basically takes a bunch of these lessons learned in the cloud native communities and try to encapsulate that in a tool that you can start using for all these shared concerns. Dapper is another project that you install on your Kubernetes clusters, right? So it's a like Kubernetes extension. You will install some components into Dapper, and then you are going to, whenever you deploy a new application into your cluster, you can say, I want to enable this application with some Dapper functionality, and we will take a look at what are those functionalities now. So if you go to the website, you will see that it's described as APIs for solving distributed application challenges. And that at first to me sounds very abstract and not very concrete. But then when you see the topics that are being covered here, like publishing and subscribing to notifications or messages or events, right? That's a common thing that you're going to do with your applications. Service-to-service invocation and resiliency between the services. That's another thing that cloud-native applications will do. State management, the thing that I mentioned before, right? Storing state or reading state from a database or from a key value store or from a bucket or from different places, right? Like that's something that your applications will do. And output, input bindings communicated with external APIs, secret managements, reading credentials to be able to connect to stuff. And again, that's kind of like pretty much what Dapper is trying to encode into different concepts and different APIs. And one of them is like the state store concept, right? No matter which application you want to store or read a state from a database or from a key value store, we will have an API for that. If we want to emit messages, again, we will have a different API for that, but we will enable developers to call that API and try to separate them for knowing which infrastructure are we going to use to provide these behaviors. Right? And again, I know that sounds pretty abstract, so we will take a look at an example of that. Service invocation, the same. We want to make sure that our service invocation and interactions are, resilient and they can work, and we can also measure them and see what's going wrong when things go bad. And when you go back to that list, right, we try to map to that week's article all the things that are being provided by Dapper, and it's pretty large. Like the coverage is pretty large, and I'm working right now on an integration with feature flags as well. With a project that's called Open Feature in the CNCF to make sure that we have APIs for doing feature flagging. So this basically means that if you deploy your application in a cluster that has Dapper installed, and you say that your application is Dapper enabled, you will start getting all these benefits kind of like out of the box. You can build your own tools to do the same, but we are trying to provide a generic tool that will do it for you for, let's say, 90% of the cases. Dapper, it's not going to solve your relationship problems. It's not going to solve everything. Right? But it's going to solve some of the shared concerns that your services will have. A/B testing, if we add A/B testing there to the list, the tool that I showed you before, Knative will solve that, and probably HTTP header-based routing as well. Cookies, that's a little bit more discussable depending on what do you want to do. So how does it work? When you deploy an application, let's say a Java application or a Go application into a Kubernetes cluster, that's a container. And when you are defining how that application gets deployed, you can add a couple of annotations to the application to say, I want Dapper to take care of some functionality of this application. Dapper will inject a sidecar into that container, right? So we have a Kubernetes pod that has another container running, and that Dapper sidecar is exposing a local HTTP and gRPC endpoints for your applications to interact with. So now if you want to store data from your application, the only thing that you need to do is you need to make an HTTP request or a gRPC request to this sidecar that is running in the same context of your application. So there is no network call, it's just a local call to the same host, to localhost, doing an HTTP request from your application if you want to store or read data from a persistent store. If you want to emit a message, instead of like having a RabbitMQ or a Kafka client embedded inside your application, you just call the Dapper sidecar APIs to emit an event. It's that simple. And because it works there like at the sidecar level, exposing HTTP and gRPC endpoints, no matter which language do you use, you will have the same functionality to do all these like shared functionalities, right? You can see also that if one application wants to call another, that call can go through the Dapper sidecars as well, and that's where you can inject all the resiliency policies, for example, retry mechanisms, and and how to deal with exceptions and a bunch of other things. So that's pretty much what Dapper is doing. And just to explain a little bit more in the context of the example that I showed you before, I told you that I have like 4 services, like the front end, an application that is writing data, an application that is reading data, and an application that is subscribing to notifications. When I deploy all these applications to Kubernetes, I basically created Knative services for the auto-scaling and also for the traffic management stuff. But I've also enabled all these applications with the Dapper sidecar in there. That basically means that I now can configure Dapper components to enable my applications with these different functionalities. So Dapper has this declarative way of saying, okay, I want to store data, so I will define a state store component that will connect to a persistent storage. It can be Redis, Postgres, it can be a cloud provider database, whatever you want to use to store data for a long time, and Dapper will actually abstract away that implementation from the application. I did the same for the PubSub component, which is the one that you use to emit messages and consume messages across different applications. The nice thing about this approach is that, I'm separating my application from the infrastructure that I'm using. That allows me to do stuff like quickly change my application logic without actually knowing which infrastructure I'm using. It also gives me the possibility of changing the infrastructure that I'm using without changing the application code. The more that we push those away, the more independent these services are. Again, you cannot solve all the problems with this, but there are some problems that will actually benefit from using this approach. And I don't know you, I'm really terrified by the Cassandra logo. That gives me nightmares. I don't know why. That eye looking at that, Cassandra is good anyways, but the logo, it's a little bit creepy. So please remove that from the recording. So my demo 3, it's not a demo, but it's a little bit more of showing how that works. It's more showing kind of like the code that I've used to create these applications. And mostly the application that it's doing most of the work is an application that it's called the write application, the one that it's writing the values to the database, basically. And it's not only doing that, but it's also emitting an event every time that we save something into the database. So if you take a look, this is a Go application, pretty simple Go application. If you're not the Go developer, that doesn't matter. You can see here that the only dependency that I'm adding is the Dapper SDK, right? And the only reason why I'm adding this is because I'm really lazy. I didn't want to write like HTTP or gRPC request by hand. By adding the SDK, you can actually just have a nice API to call these things without writing the raw request. But if you don't want to even depend on Dapper, you can just remove that and use HTTP and gRPC straight away. The important thing in here is that I'm storing data into a Redis database, but my application doesn't know anything about it. Right. So I haven't included any Redis dependency into my application to do that. You can see here that the only thing that I have is something called state store name. This is a static variable, like a definition. And it has like a state store. That's the name of the place where I want to store or read information from. And you can see here that I'm using the Dapper client API here to get state. Pretty simple. I'm just giving the name of from where do I want to read this state. It's a string, remember, and then the key of where those values are. And in order to save state, it's pretty much the same, right? Like where do I want to store and what's the key that I want to use to store that data. Lastly here, I have like the publish event. Again, here, in order to publish an event, the only thing that I need to have is 2 strings. One is the name of the component where I want to publish the event, and then the topic that I want to use to do that. Again, my application doesn't have any dependency to Kafka or RabbitMQ or anything else. It just knows these names. So in order for that to work, what I need to have is I need to have some Dapper components configured there. So in my cluster, I have 2 Dapper components, one called state store, as the same as the string that I have in my application, and then the other one, notification PubSub, which is the other string that I didn't show much, but it's that one, right? So now my application can store and read data and also emit events, and those events will be routed to all the applications that are listening for those events. If I describe this, so let me just do quickly this, describe component state store, let's say. Let's take a look at this. This is the only important part of the resource. The other stuff is like Kubernetes stuff that you can ignore. Is here, this is kind of like how I tell Dapr, okay, I want this state store that it's called a state store to store data into this instance of Redis, right? Like I have a Redis instance running somewhere, so that's my Redis host. And of course, this is the Redis password. You can use a secret for that. I was lazy again and just put the password in there. But the only thing, the interesting part in here is that I have this configuration for this setup right now, but I can go and create another configuration for use PostgreSQL, or I can use, how is it called, like in-memory database in Google Cloud to store the same thing in a Google Cloud instance. And I don't need to change anything on my application to be able to use that. And I think that that's pretty powerful. The same thing applies for the PubSub mechanism. You can go and change the configuration to use Kafka or RabbitMQ or Pulsar or any other message broker that you want to use. It's really nice. In the Dapper website, you can see all the implementations, and it's a pretty active community. So we have tons of different implementations for each of these components. One more thing that I wanted to show here is that if you are a Java application developer, again, it's pretty simple. It's pretty much the same. I wanted to show that this doesn't depend on the language, right? And we have SDKs for all the languages, but again, if you can send an HTTP request, you can actually use Dapr. And in this case, just same application, same functionality, using the Dapr abstractions to, in this case, do the same thing that the right application is doing, but now in Java, right? So the only difference in logic is this line that basically attaches like the Java dash into the content that I'm storing, just to make sure that we see that the Java version is working. But you can see here, get state, same way, save state, and publish event, same functionality exposed, different languages. But it's really important. It's the same behavior, because now we are delegating on the behavior and the implementation on the Dapr components. They have a specification, so no matter which language you're using, you're getting the same behavior. That's something that it gets really difficult when, for example, you're using abstractions on your programming languages. If you choose to use Spring Boot, for example, you will have a bunch of abstractions. And then if you want to communicate that with the Go application, well, it's pretty hard to guarantee that the Java and the Go application are doing exactly the same when they are storing data, or they are connecting in the same way to the database, let's say. This actually removes the responsibility from the application. I don't think that I have enough time. I think I have 3 minutes left to show that, but I can actually, I want to do it. Sorry, I want to do it. I want to change that right application to use the Java version. And the Java version is not optimized, so I know that Alina will be not happy with this.
I'm paying a lot of attention.
Yeah, this is going to take forever to start because it's Java, so I need to optimize it. I need to optimize it for sure. But yeah, so I'm just changing. This is kind of like the nice thing about all these tools. Again, it doesn't really matter what that containers have in there. Kubernetes will run it for me, and as soon as it's connecting to the same things, it should work, right? So again, it's creating. It's going to take 10 seconds or 15 seconds to get up and started. It's starting, right? But that's the whole point. Like Polyglot, enabling developers using a polyglot approach, where we are pushing all these responsibilities to the platform side for platform engineers to wire up and make all these decisions about the tools that we want to use. Let me see if it's up. It is up, and it's killing the other one, so I guess that it's also ready. So if I go here, access the application, hello, go to from, let's see, fingers crossed. Oh, of course, like the last demo. There you go. Hello from Java. Okay, so it's working. I'm getting the asynchronous notifications as well because I haven't changed any of the application there. But same functionality, different stacks, reusing kind of like the same platform provider functionality. And I have 1 more minute to close it up, 2 minutes. So what we have covered is that idea of talking about platform capabilities. We started with the platform APIs, creating development environments, and then we moved into platform capabilities about what can we provide developers, how can we enable developers to be more efficient when they are writing their applications. We looked into Knative for release strategies, and we looked into Dapper for this functionality abstractions, capability abstractions. And there is a lot of much more stuff that we can be doing in the cloud native space to make this journey much easier. I would love to have a place where I have like this kind of like save state or read state or publish event functionality without depending on Dapper itself. but it's more, again, like another abstraction layer that you can provide to choose different tools to implement that functionality. So we are also working on some of that. So stay tuned. I will be probably writing a little bit about that as well. So to sum up, Kubernetes is not so easy. We actually need these platform engineering talks, these concepts, and this work that we are doing in the CNCF to make the Kubernetes journey easier for newer people. Tools like VCluster, something that I've showed there is that I've created this small cluster inside the cluster that I already have running. I didn't need to create another expensive Kubernetes cluster to enable developers. So take a look at that project if you're interested in that. And I've used Crossplane to provision cloud resources. In the same way that I've created a VCluster, I could be creating a Google Cloud cluster or an AWS cluster automatically without pushing people to know or learn about AWS. And tools like Dapper and Knative, I think that they are pretty good at that story of enabling teams with experimentation tools, but also the right abstractions for application developers to build more and more features. I think that that's my presentation, 50 minutes sharp. I'm surprised about myself. I'm really bad at time management. That's my vlog. So, thank you very much.
Thank you.